How can you find the limit of this function? Well, the hint for me about what we're supposed to do here is that we have a sum or product, and one of them is a square root. Often when that's the case, you're going to have to multiply by its conjugate. What I mean by that is multiply this function by x plus the square root of x squared plus 1 over itself. Remember, you can multiply it by anything as long as you multiply the top and bottom by the same thing. So what I have here now is that equals the limit as x approaches infinity of. Now I'm going to FOIL this out. This is actually a difference of squares, and that's why we chose to multiply it by this. Notice it's x and x, same thing. Root x squared plus 1, root x squared plus 1, same thing. The only thing that differs is the sign in between them. What you get is x squared minus, and then the thing that's under your square root. The square root actually cancels itself out when you multiply it by itself with another square root, because this exponent of a half and this exponent of a half combine to make the exponent of 1. Anyways, your bottom is still what you multiplied by. This looks a little better. And in fact, I think you'll find that when you multiply and simplify the top, you get x squared minus x squared, which is 0, and negative 1. Negative 1 over x squared plus x squared plus 1, the square root of that. Beautiful. Alright, so now all we have to do is figure out what the limit as x approaches infinity is. Well, as x gets closer and closer to infinity, this stays as negative 1. That's not going to change. And we get infinity plus, well, infinity on the bottom here. So the bottom gets extraordinarily big, infinitely big. The numerator stays as negative 1. Negative 1 divided by a really big number turns out to approach 0. It never actually equals 0, but it approaches 0, and that's what the limit's all about. The key to this question is identifying that you need to multiply by the conjugate in order to evaluate the limit. Difference of squares simplifies and ends up giving you a very nice number in the end. Hey, best of luck to you.